Hello, my name is Alicia Vallorani, and today I will be describing my proposed dissertation research examining the coordination of social attention and the mentalizing network during social interactions between friends. Social interactions are the building blocks of social and social brain development. During emerging adulthood, a developmental period of increased independence and self-exploration, peer interactions are particularly important for solidifying social skills necessary for adulthood. Theory suggests engaging in social interactions requires the coordination of social attention, gazing at interaction partners, and mentalizing, the ability to recognize and interpret the mental states and intentions of others. However, these processes have commonly been studied separately and outside of the interaction context, lessening our ability to understand how social attention and mentalizing coordinate moment to moment to enable social interaction. The mentalizing network, a social brain network including the medial prefrontal cortex and the temporal parietal junction, may use information attained through social attention to interpret ongoing social interactions and to make decisions about how to navigate complex social environments. However, historically, it has been challenging to emulate naturalistic social interactions in the scanner to assess mentalizing. Second-person neuroscience techniques, which present participants with stimuli that are interactive, are better equipped to investigate underlying social processes than are more traditional third-person neuroscience techniques. Indeed, using ostensible social interactions, individuals exhibit greater mentalizing network activity when individuals believe they are interacting with true others rather than with a computer, suggesting the potential benefits of using naturalistic social interactions to understand the mentalizing network. Natural social interactions are complex, immersive, and dynamic, requiring individuals to track multiple streams of information simultaneously to successfully navigate an interaction. Thus, to understand how social attention and mentalizing coordinate during social interactions, it is necessary to take a naturalistic approach. Further, positive affect is known to foster social relationships and direct gaze during social interactions. Thus, the coordination of social attention and mentalizing might be greatest in the presence of positive affect. The current study uses mobile eye tracking during a social interaction between friends to assess naturalistic social attention, as well as to create naturalistic stimuli for a scanner task designed to assess mentalizing. This method provides a needed test of how social attention and mentalizing coordinate during real-world social interactions. 40 participants will complete the study, and to date, 5 dyads have begun participation. At Visit 1, participants engage in a social interaction designed to elicit both positive and negative affect while wearing the mobile eye tracking system. Participants also report their feelings about the social interaction and their friend. This first video is an example of positive affect. We use this third-person view to code the dyads for affect and create stimuli for the fMRI task. At Visit 2, participants relive the social interaction by watching positive, neutral, and negative clips from the social interaction from both their own and their friend's perspective, while fMRI data are being collected. Participants again report on their feelings about the social interaction. These second videos are an example of the videos that participants would see for the fMRI task. Both participants see the same stimuli, but in a flipped order, so that participants always see their perspective first and then their friend's perspective. Mobile eye tracking data, shown on the left, are pre-processed in pupil player, and then machine learning is employed to assess gaze position based on the location of the green dot. fMRI data are pre-processed using fMRI prep. fMRI bold signal is extracted and deconvolved to align with the timing of the mobile eye tracking data. To investigate the coordination of social attention and mentalizing network connectivity, I will use multi-level structural equation modeling. I anticipate that greater positive connectivity between the medial prefrontal cortex and the temporal parietal junction, which would represent more communication within the mentalizing network, will be associated with moments when participants are gazing at their peer, particularly in the context of positive affect. This finding would suggest coordination between social attention and mentalizing during naturalistic social interactions and would provide a foundation for future data collections, assessing individual differences in this process that might mark individuals who struggle with social interactions, such as those living with social anxiety disorder. And with that, I would like to thank all of my collaborators as well as my funding sources, and thank you for your time.